Okay, welcome back, dear friends. So today I am coming once again with one more presentation in continuation with what we did in our previous presentation. A quick recall, we were discussing about the various communication technologies that we use in our IoT scenario, and in the previous presentation we have looked into the RF radio frequency communication transceivers modules. Then we have seen what exactly we mean by GSM, global system for mobile, then GPRS, right, then UMTS, LTE, even WiMAX. So these are some of the the communication technologies that we have discussed by looking into their characteristic features, their some of the major advantages as well as the drawbacks, right? So this is what we have seen in the previous presentation. So in continuation with that, today we will start discussing about a few more such things. Let us start with the wireless USB, right? So all of you are very much familiar with USB. Again, we have the wired USB also, that I will definitely take up when I discuss about the wired communication technologies. So far we have been discussing about the wireless communication technologies, right? So USB, as all of you know, universal serial bus. Okay, USB stands for universal serial bus. So no need to mention that how many of you have seen USBs, right? So almost everyone is very much used to the USB, but now we have been talking here about the wireless USB, right, universal serial bus. So it is basically the wireless extension of USB 2.0, right? Technically speaking, it is called as USB 2.0, and it operates at a ultra wide band. So at what frequency it operates, what are its data transfer capabilities, right? So in which scenario this USB is capable of operating, all those things are required to be known, being the engineering students. Okay, so that is where you will be able to know the technical specifications of USB rather than the general aspects what probably each and everyone knows. When you put it in the USB slot, it is going to uh, make sure that the data is transferred from host to the device. Okay, so now you can see here it is 5.1 gigahertz to 10.6 gigahertz frequency, very fast. So maybe these specifications, I don't say that these are the exact specifications, as you have more and more modern technologies coming up. Definitely you can go with still higher frequency. As and when we come across those things, we shall discuss about those things. Okay, so USB 2.0 operates at ultra wideband 5.1 gigahertz to 10.6 gigahertz frequency. Short range PAN, it is one of the short range personal area network, right? So we have started from the personal area network, so where you have got a small network of your own, having some computers, right, or some tablets, the connectivity and all, right? So for the short range personal area network, so the wireless USB is one of the preferred communication technologies, right? High speed 480 mbps to 3 meters, or 110 mbps up to 10-meter channel, right? So this is for giving the specification of the wireless USB, right? And you have the host wire adapter, right? So these are the technical terminologies, again you need to be familiar with. Host wireless adapter, HWA, and a device wireless adapter, right? So now what exactly you mean by host and device here? One is the host, right, another is the device. How do you differentiate between the host and device? So basically a host is always having a unique IP address, unique IP address. This you should always know. The host will be having a unique IP address, and device will be always having a unique MAC address. MAC in the sense media access control, media access control. Okay, so now see, suppose if I got a connected system, right? So let us say that this is the host. It is getting connected to so many computers, something like this. This is another one, right? So now this is one, this is one, this is one. These are all called as the devices, D1, D2, D3, and this is the host here, right? So this host is always characterized by a unique IP address, and all these are having the MAC addresses. That means they have the address, media access control address, within the network to which they are connected to a particular host, right? So the IP protocol or the IP address is given to only the host. In this way you will be able to differentiate between a host and the device. Okay, so now coming back here, you can see a host wire adapter and a device wire adapter, wireless USB solution, supports the dual role devices, DRDs. So what do you mean by dual role devices, DRD? The one which has the capability of acting both host as well as the device. You have the OTG cables and all, right? You must have heard about this OTG, on the go cables, right? So now here the provision is there to have a particular device to act either as a host as well as the device. I have already told you how do you differentiate between a host and the device. Host with a unique IP address, wherein your device will be having the media access control or the MAC address. So when in a system you may have one host and different devices, and different devices will be having different MAC IDs, so that they can get connected in a network along with the host. So host can take care of the different devices in the data transfer. Okay, so this is what is the meaning of this. You have the wireless USB supporting the dual role devices, DRDs. That means a device can be a USB device as well as limited capability host. Again, what is the meaning of the limited capability and all? That all comes with the specifications as long as your communication scenario is concerned, right? So let us not move into those details. One which is having the capability of both acting as a host, maybe with limited capability, and also as the device. So definitely these kind of devices are supported by your wireless USB. Okay, so now with that we will go to the next slide, wherein we have some more important aspects related to the wireless USB, right? You can see here, wireless extension of USB 2.0 operates in ultra wide band of 5.1 gigahertz to 10.6 gigahertz. Then for short range personal area network, so 480 Mbps 3-meter distance, 110 Mbps 10-meter channel, and it also supports DRD. This is what is the summary of whatever I have just spoken before this. Okay, so now that is about your wireless USB. Okay, so now let us come to the next category. Now so far in this case, right, we have been discussing all about the wireless communication technologies, right from your near field communication devices, NFCs. I will just quickly recall whatever we have studied so far. Near field communication devices, followed by Bluetooth, right, followed by Zigbee, followed by Wi-Fi. Then after that we have seen something about the RF transceivers, RF modules, followed by GPRS, GSM, right? So and WiMAX. So those are some of the other wireless technologies that we have used. Finally we have come to the wireless USBs. These are all the wireless arrangements for us to have the communication between two entities, as long as the physical and data link layer is concerned in our IoT scenario. Okay, so now with that background, let us come to the next point which we are supposed to discuss here, that is the wire communication technology. That means the communication technology that makes use of the physical channels for the data transfer. So in this we will have the first one, UART. All of you must be knowing what exactly is the meaning of UART, universal asynchronous receiver and transmitter, and you also have USART, right, universal synchronous receiver and transmitter, right. I will come to these points, right, what exactly we mean by UART and USART. Then serial peripheral interface, SPI, serial peripheral interface, serial peripheral interface, serial peripheral interface. Then you have got the Ethernet, right, inter integrated circuits or inter integrate circuit, I2C. Then you have the wired USB, which you are very much familiar with, right. So these are some of the other technologies that we need to look into as long as the communication technologies under wired communication technologies are concerned. Okay, now let us try to see one by one these things very quickly. First one is, as I have already told you, UART or USART, universal asynchronous receiver and transmitter, universal synchronous receiver and transmitter, serial communication. So this does not need too much of explanation, since you have already undergone a course on microcontroller, right. So when you have undergone a course on microcontroller, you know how exactly the serial communication takes place between a transmitter and receiver. If I call it as transmitter and if I call it as receiver, so the data move in the serial fashion, zeros and ones here, right. You have the start bit, you have the stop bit, right. So you have sometimes the parity bits to check the integrity of the data, right. The data starts moving in this direction. Now if you have the synchronous communication, then you have the transmitter and receiver both are synchronized with the same clock frequency, right. So this frequency between the transmitter and receiver will remain same. So that is called as synchronous communication, universal synchronous receiver and transmitter, or USART, right. So here the advantage of this is definitely you can always have the data transfer at a higher speed, because at what rate your transmitter is sending the data, at the same rate your receiver will be able to receive the data, because both are clocked by the same frequency. Okay, so this is one communication which you probably are familiar with as long as your microcontroller study is over, right. It is over and you are familiar with these things. So now another one here is the UART, right, wherein you have the transmitter and you have receiver, but in this case the transmitter and receiver, they work or they operate with different frequency. Let me call this as F1, this as F2. When the transmitter and receiver, they operate at different frequencies, then you know what are the problems. So there will be data mismatch when the serial data flow takes place from transmitter to receiver. So you may not be able to receive the data at the exact rate what is being transferred from the transmitter. So you need to have a lot of algorithms for the parity checking to make sure that the data is received in the proper format, the proper fashion. There is no exclusion of the data or there is no redundancy of the data. All those things are to be properly taken care of. So that needs a different kind of technology and its proper implementation, where you can call it as parity checking or something like that. Okay, so but here this system is again useful, wherein you need the data to be transmitted over a long distance, where it is not possible for us to connect both the transmitter and receiver physically with the same frequency clock, right. Sometimes if the distance is too much, it is not possible for us to connect both the transmitter and receiver with the same frequency. There probably this kind of methods are used. So now This is again by making use of the physical channels. You may use your telephone lines or any other kind of physical media through which the information is exchanged between the transmitter and receiver. Okay, so this is one thing. As long as our UART or USART is concerned, right? So then we have one more, you can see here, that is called as serial peripheral interface, SPI, serial peripheral interface. So what exactly is the meaning of serial peripheral interface? Basically it is also very similar to what we have seen in the case of UART or USART, but here we will be having two things. One is called as, or one is assigned as the master, and of course the other one I need not mention, this is the slave. There will be two entities between which the data is exchanged in the serial fashion. So the source of serial synchronous output, right? The source of serial synchronous output is referred to as the master, right? And the receiver of the serial synchronous input is referred to as slave, right? Source and the destination. Source is called as the master and the destination or the receiver is called as the slave here. And in this case also there are four possible type of modes of operation, right? One is called SCLK, that is the synchronous clock. Okay, second one is called MISO, that is called as master in slave out. This is one of the modes of operation. Then you have got MOSI, that is master out slave in, and the last one is called slave select. I am not going into much details of these technologies or the the principle behind these things. These are the four type of operation depending upon whether the communication is being established from the master to slave or slave to master, along with the generation of the clock and also the selection of the slave. These are the four possible types of the communications that take place in the serial communication interface or serial peripheral interface. So this is also very similar to what we have seen in the case of UART or USART. Okay, so now after having seen your UART or USART and SPI, let us now move on to the next communication technology, wired communication technology, which is called as I2C bus, right? So I have already told about what is I2C bus, inter integrated circuit. So this is referred to as inter integrated circuit. All of you know about integrated circuit. When I say integrated circuit, definitely will speak about the ICs. So then what do you mean by inter integrated circuits, right? So now see, so you may have some sensors, you may have some actuators, you may have some flash memory, touch screens or something like that. So if at all they need to exchange the data for different processes for which they are intended to, right? So generally the ICs, the different ICs, the application specific ICs mutually network through a common synchronous serial bus, which is called as inter integrated circuit, right? So the different ICs are dedicated for different purpose. You may have sensors, you may have actuators, you may have flash memories, touch screens, so many examples. If at all they want to mutually communicate with each other, then they make use of a common resource or the common bus, which is the serial bus, which is referred to as inter integrated circuit, right? So again here we have got four different modes, right? I am not going into the much details of this. One is called master transmit, then you have one more as master receive. Again, the analogy is similar to what we had in the case of SPI, master and slave. Then you have slave transmit, then you have slave receive, right? Master transmit, master receive, slave transmit, and slave receive, right? So this is a general thing as long as our I2C communication is concerned. But there are certain standards. In fact, one more thing what I need to mention here, this particular I2C communication, right? It was started by Philips way back, right? Philips is the pioneer of giving this technology, Philips semiconductors rather, right? So there are several standards which are capable of operating at a speed of 100 kbps, right? Then you have got 400 kbps and so on. There are different standards, I mean the operating speeds, right? The data transfer speeds over which the different standards of this I2C communication takes place. Okay, so this is about the I2C communication. What we have seen here, mutual IC networking through a common synchronous serial bus. This is what is the meaning of I2C, right? Then we have wired USB. We have already spoken about the wireless USB, right? We have seen what exactly we mean by wireless USB. Now wired USB everyone is very much familiar with. You have all used the USBs, universal serial bus, right? So bus between host and number of interconnected peripheral devices, right? So let us not go into the other details, but the technicality behind it. So we can use this wired USB up to a speed of 12 Mbps, and some cases nowadays you can even exceed that depending upon the modern technologies which are coming up. Maximum 127 devices can connect with a host at a particular time. And again, as long as the wired USB is concerned, we have got three standards there. So one is USB 1.1, which is having the operating speed range of 1.5 to 12 Mbps, right? Then USB 2.0, which we are all very much familiar with nowadays, right? It can go up to 480 Mbps. Please look here, up to 12 Mbps I had mentioned, but your USB 2.0 standard gives us the operating speed up to 480 Mbps. And the one more, which is USB 3.0, it is capable of giving the speed up to as you can see here, that is 5 Gbps. And one more you have, that is the fourth one, USB 3. One second, I just zoom it out. Yeah, 3.1 super speed, right? So it gives us the speed up to 10 Gbps, right? So these are the four different types of the USB nomenclatures that we have under the wireless USB, right? Sorry, under wired USB. But presently we are all using this standard, that is USB 2.0, that is up to 480 Mbps, right? So this is as far as the wired USB is concerned, right? So now what we have seen here is in the serial communication devices, as long as the wired communication is concerned, UART, USART, right? Then we have seen what is a serial peripheral interface. Then we have seen what do we mean by I2C bus, right? Integrated circuit bus, the serial bus. Then we have seen what is wired USB. Now we have one more important thing which we generally use in our day-to-day internet terminologies, that is called as the Ethernet, right? That is the Ethernet. Okay, so what is the Ethernet? Now you all know about the Wi-Fi connections, right? So if at all you have the wired connection, which is the counterpart of your Wi-Fi connection, that is called as the Ethernet. And for your understanding purpose, I have pasted a small diagram here so that you can easily conceive what exactly is the Ethernet communication. So you can say this is the Ethernet box here, right? You have got several points here. You can connect using the corresponding cable. Could it be there are different standards for these cables, right? So you have to select only those cable which we generally call it as the Ethernet cables, and from this, using the wired connection, you can always take it to your computer or whichever device is considered as the device there, right? Host and device, that analogy you have to again bring it back here, right? So as long as the Ethernet is concerned, again it is originated from your IEEE 802.2 standard. It is also conceived from your ISO 8802.2 standard, because ISO is another agency which has given us a lot of communication standards, right? So IEEE 802.2 as well as ISO 8802.2, both these protocols specify about what is to be done or what is to be followed in our Ethernet communication. It is basically the protocol for LAN. Okay, it is basically the protocol for the local area network. Again, personal area network. Then you come to the local area network, where if at all you want to establish the connectivity between the devices using the wired connection, then Ethernet is the solution, right? Protocol for LAN. And here there are different aspects related to how exactly the communication takes place, right? So what is the format of your packets, right? So how you have the media access control, MAC, or IP address given to the things, all those things will come, right? Each frame consists of a header, enables the service of local devices, nodes, computers, systems, and local resources. But here you please try to understand, this Ethernet is basically a counterpart of our Wi-Fi network which we are using in the local area network. And again, in order to establish the connection between the host and the different connected devices, there are certain protocols or standards to be followed here, and these standards are as per either IEEE 802.2 or ISO 8802.2, right? So there are different other aspects related to the Ethernet, related to the transmission speed and other things, right? You have up to 10 Mbps, you can have up to 10 Mbps speed, right? But this is not the speed, as I have already told you, it keeps changing. You can have up to 100 Mbps as long as the Ethernet is concerned. One is the 10 Mbps, and you have another 100 Mbps. That all depends upon what kind of technology that you are using, that is called as unshielded as well as shielded wires. Then you have got 1 Gbps, right, or 1000 Mbps, 1 Gbps, that comes in the high quality coaxial cable. Depending upon the standards in the cable, whatever we have, right? So the corresponding speed also keeps changing. Then you have 4 Gbps, 100, right? From 10 Mbps we have gone up to 4 Gbps. It is called as the twisted pair wiring, right? So twisted pair. Again, these are all the different cable technologies that we use in our communication scenario. And finally, right, you have one more, that is up to 10 Gbps. 10 Gbps. See, we started from 10 Mbps till 10 Gbps, and again when I say that it is 10 Gbps, you can definitely understand we use the optical fibers. Optical fiber communication is the fastest available wired communication now, right? Of course, on outer side only it is physically connected. Inside, the optical signals will be going. That's a different thing altogether, right? So up to we can have 10 Gbps, and even as of now there could be even higher speeds as well, even depending upon the technologies that have been developed in our um, you know this Ethernet communication. Okay, so this is the another technology which I have just made a mention. As long as the wired communication is concerned, right, we have been discussing about the wired communication technologies, right. We again, I repeat, we started from the first one, UART or USART, then we have seen SPI, serial peripheral interface, I2C bus, then wireless USB, then finally the Ethernet. These are the 5 technologies which we use as long as the wired communication technologies are concerned in our IoT scenario, right. So now in a nutshell, we have discussed about the various communication technologies that is used in the IoT scenario, and not necessary that all these technologies are inevitable in the IoT scenario. Depending upon our requirement, we may selectively take up some of the communication technologies. And in general, right, as an introductory course, it is always very essential for you to understand the very basic gists of the different communication technologies. I have tried to convey right from your near field communication devices till the Ethernet, how exactly it is possible to characterize the different communication technologies, whether they are the the wireless technologies or they are the wired technologies, right. So in our next presentation, let me have the overall comparison of some of the prominent technologies that we have seen here in a single window, so that you will be able to properly understand in a general sense, so the comparison between the different technologies and which one is better in which attribute, that we will see in our next presentation. So if you have any doubt or any difficulty in this presentation, please get back to me. Thank you.